Okay, so Stott, you are up first.
So tell me if you can see that.
Can't see anything yet. Oh, yeah.
Yay.
Looks good. Perfect.
Cool. So whenever we're starting?
Yep, you're good.
Right. Hi, everyone. Welcome to the session. This is on Pyrobrite, which is a deep assignment and auto-assessment tool from Microsoft. I'm Stott. I'm a principal cloud advocate at Microsoft. Hi, welcome to this session, Pyrobrite, a deep assignment and auto-assessment tool. I'm Stott, a principal cloud advocate at Microsoft. Many of you wish to be able to offer auto-assessment solutions for your classes. At present, you may be assessing student performance, clustering them, and then focusing your TAs and academic support on those students who need the most support. But an important element of all students' learning is they get meaningful feedback. So this presents a number of challenges for you as an educator. Firstly, you need to also quickly iterate your assignments and ensure you provide secure and stable environments. You need to continually master and learn new technologies and approaches to teaching. You have a desire for students to collaborate and work in teams. And all this has simply got more difficult during COVID, with students, staff and TAs being remote. This has also presented a number of operation challenges, which hopefully this week you have more understanding of. But these include infrastructure. Do you use Jupyter, virtual machines, containers? What about administration, security and authentication? Content, do you build your own or use resources already provided? Grading solutions or submission processes, which one, how and where? What languages do you teach? Hopefully this week you've learned a lot about Python and R and how teaching assistants can help scale and provide that feedback to learners. But not all institutions have the resources available to support this. As Microsoft, we have Microsoft Learn. Microsoft Learn is an online resource which is ideal for your primers. These include hands-on labs, assignments and quizzes for students to complete. We also have support for things like LTI, so you can use an LTI application to embed Microsoft Learn resources into your existing curriculum. And students can sign in with their authentication from your departments and organisations so they can take that learning journey and learning history with them. We also have a great selection of tools. Visual Studio Code is our IDE, and GitHub Codespaces is simply Visual Studio Code in a browser and directly associated to your course GitHub repos. If you're interested in learning more about these, head over to the expo where we'll be showcasing some of these features, or you can look at the URL provided. All these experiences support Jupyter, Python, and R, and it allows students to do these assignments and tasks both locally on their own machines or within the cloud. So over the last 18 months, we've been working with lots of educators around the problems they face within auto-assessment. And I want to spend a bit more time talking about auto-assessment. Auto-assessment is actually different to auto-grading. Many of you are actually using technologies such as OKPy, Otter, or MB Grader today. But we've been working with educators to understand those issues which are actually faced during the auto-assessment process. Number one, as teachers, you don't want to enforce a structure of a solution. You want to be able to give students a blank starting point and then understand what the student learned and how they actually learn those development skills. You want students to practice and design processes, again by using algorithms or functions or specific languages or specific areas of those languages. Again, when the student makes a mistake, you want to be able to provide meaningful feedback to those students. You want to be able to analyse the complexity of their solutions. And most importantly, from an academic standpoint, you want to understand plagiarism and have plagiarism detection. But all this needs to be user-friendly. So from this research, we've developed an open source auto-assessment tool which works with your existing grading solutions such as Otter, MB Grader, OKPy, and there's many more out there as well. What I want to do now is do a quick demo of what Pyrobrite is. Pyrobrite is a pedagogical auto-assessment library for Python. The main goals of Pyrobrite, as compared to other more conventional auto-graders, is to allow instructors to write more complex assignments that don't require students to follow a rigid structure for their solution. This allows learners to practice algorithm design, co-design and solution implementation while receiving quick and meaningful pedagogical feedback. What I'd like to do for the next few minutes is just walk through some of the demos we have available in the demos folder on the Pyrobrite GitHub repo. The first example we'll look at is the medium example. In this, students are asked to implement the medium function, and Pyrobrite is used to ensure that student solutions correctly implement the algorithm. In this notebook, we have a reference implementation for the medium function. A reference implementation is simply a solution that has been marked up with various annotations that assert the presence of different values and conditions on those values. In this example, we have an implementation of the medium algorithm and a series of annotations that assert the presence of a few values to check that students are computing values that are required to determine the actual value of the medium. In this example, the first values we assert is that the student should be sorting the list that they receive into the median function. We'll then see that they should be determining the length of that list in order to correctly compute the index at which the median lies in the sorted list. Finally, at the end of the notebook, we'll see an annotation that asserts that the correct value, the value which we know in the test case, should be the median, and is it found in memory. All of these annotations come with success and failure messages, and these messages will be returned to the student when they will run Pyrobrite, and also to the instructor when they run Pyrobrite, as a means of providing meaningful feedback to both the educator and student. Note that all submissions in this demo return the correct value for the test case and would actually pass the test of a conventional auto-grading solution. However, in this example submission, we can see that the student has imported NumPy and returns the value of NP medium called on the inputted list. Because the assignment was for students to implement the algorithm themselves, this is not a valid solution, but it does return the correct value. An auto-grader would not be able to catch that, and this is where Pyrobrite comes in. If we go and look at the output for this submission, we'll see that the student has received a few messages that let them know that the instructor know that they weren't on the right track and are missing some key values that are needed to satisfy the reference. Now let's run Pyrobrite. The process of running Pyrobrite is as follows. We first start by compiling a reference implementation, which is in the notebook that I showed earlier. After we compiled the reference implementation, we can save it to a file if needed, so we cannot reload it for later use without re-executing the notebook, or we can go straight into grading. The process of grading is actually a two-stage process. First, we start by generating a series of memory footprints, which are encapsulated in the student's implementation objects. To do this, simply execute the notebook or the student's submission with a trace function that records values that it observes in the memory. Once we have these memory footprints, we can then use it to run against the reference implementation to check that we have the right values in the memory. Here we can see the results of Pyrobrite against submissions in the demo. If we look at submissions 2, which is the one that imported NumPy, we can see a series of error messages that Pyrobrite was expecting to find certain values that were not included in the student's submission. In this way, we can tell that a student didn't implement the algorithm in good faith, and we know not to give credit to such a submission. The next demo I'd like to take a look at is the Fibonacci demo. This is a slightly more complex solution, and in this example involves the use of multiple reference implementations. Here, students are going to be asked to implement a function that returns the nth Fibonacci number and which runs in a linear time. In this reference implementation, we have two algorithms to determine the nth Fibonacci number. The first involves the use of a hash map to remember past values, and the second involves dynamic programming. We mark up each of these implementations by creating a series of value annotations and appending them to a list. We have two lists, one for the hash map implementation and one for the dynamic programming implementation. As we run the test cases in this notebook, we'll populate these lists with the annotations and assertions the presence of the hash map itself in various stages of being filled in for the hash map implementation and the array of values needed to check the dynamic programming implementation. We also add a second kind of annotation called the time complexity annotation. This is a Pyrobrite mechanism for asserting that a named block of student code runs within a specific runtime. In this example, we've asserted that it should run in linear time. Finally, we'll have a third reference implementation created. In this last reference implementation, we'll check to see there are some markers of either an acceptable implementation in the student's memory footprint. In this way, we'll ensure that students are not implementing the naive algorithm, hence the failure message tied to the annotation. Finally, we'll create the reference implementation objects by passing a list to the reference implementation constructor along with the name of each reference implementation. Let's now look at the results of running Pyrobrite against each of the student submissions. The three submissions in the submissions directory include a hash map implementation, a dynamic program implementation, and a naive implementation. We can see in these results that the hash map implementation satisfied the hash map reference and satisfied the reference concerning that naive implementation was not being used. We can see that dynamic programming satisfied its reference implementation. And in the third example, which was the naive example, we see it failed all three references. So in conclusion, as you can see, Pyrobrite allows you to build a complex assignment in such a way that students aren't forced to rigidly adhere to set structure for their submissions, and is robust in the various failings and comparisons in conventional autograders. For more information about Pyrobrite, you can visit the GitHub repository, documentation, and try it out yourself. We also have lots of resources for students, including Azure Student, where every student has access to over $100 of free Azure credit and access to learning resources on Microsoft Learn and certification pathways, and also access to developer tools. Again, no information is required from the student in terms of credit cards, and this is completely free. For more information, look at Azure for Student. As educators, we also have a number of programs aimed directly at you. A great example of this is the Microsoft Learn Educator program, which provides a number of resources, curriculum, and professional certification pathways, which allow you to develop and blend your curriculum and create dedicated resources, and also a dedicated community of educators from across the world to help you showcase and share best practices. Again, we want you to take part in this community and be an active member in both the sharing and collaboration of materials. So I hope you found this session useful, and if you have any further questions, please don't hesitate to ask or head over to the Conference Expo where you can make contact with the team. Do you want to hand it over to the next speaker, Eric?
Okay, great. Thanks, Lee. We can loop back to this. I think that's Jessica.
Everyone, thank you so much for allowing me to come and present to everyone. I will get started. Give me 1 second just to share my screen and we'll go ahead and get going. While I am doing a tech to share my screen, of course, being a data person, I am going to put a survey up for you because I want to collect some data on you. So here is, if you are on the website, you can utilize that. However, I'm also going to put in the chat session. I will also put text message just in case you are interested in utilizing text. And I am putting both in the chat now. Done. Awesome, we already have both coming in. Yay. Okay, let me share screen so we can watch the results in live time. And sharing screen. Wonderful. Okay, let's give this about another 30 seconds and then we'll go ahead and move on. Very exciting. So we'll stop here. So we have a 60-40, not bad results at all. There is one other question. I'm going to go ahead and open this up. Let me just make sure that you can respond to the same one. That was 6043. Yep, the same results. So the next one is going to ask you which role best fits your work at the university. Wonderful.
I'm cheering for my category.
Nice, thank you. Love the interaction. Awesome. Okay, let's give about 30 more seconds and then we'll move on. Okay. Teachers, we have other curriculum coordinator. Oh, it moved a little bit on me. Okay. I'm glad I gave it the extra few seconds to talk it out. Okay. So good deal. So it looks like we have teachers as the first ranking of people that are in the room. So thank you so much. Give me 1 second. I'm gonna take this down and I'm going to go ahead and I'll do a combination of both. But before I begin, I'd like to introduce myself. My name is Jessica Lyons and I am with Tableau. And I am specifically with the academic programs under Tableau for Teaching program. However, looking at the data that we have, it looks like not only do we have teachers, but we also have students and we have a couple of other people, whether it's curriculum or not. So I'm so happy that I asked those questions because I want to make sure I cover a little bit of everything. Eric, I promise I won't go over time, and if I do, just go ahead, wave your hands and let me know because I know I can get really excited and get going. So again, my name is Jessica. I am with Tableau for Teaching. Before coming to Tableau, I was with NWEA working with K-12 school districts across the nation. I was also at Illinois State Board of Education working as a data consultant as well as doing several committee work, all in the area of data. And I was an adjunct professor for the last 8 years for the Department of Psychology. So if you can think of a psychology class, I probably have taught it. With that being said, I have recently joined Tableau, and I'm really excited for Tableau for Teaching because our whole role there is we're mission aligned and we're mission based. We understand that data is more consumed now more than ever. And with that being said, we know that we have to train people up in data. Our world is changing. It's no longer just for data scientists or data analysts, data strategists. I don't know about you guys, but I'm hearing a myriad of new terms and technology for this world as we're still trying to explore that, which I think that's why we're all here at the conference today. So I'm very excited about this. So as I move on, I'm going to go ahead and share screen. And what I'll do is actually show live first, tell you a little bit about Tableau for those who don't know what it is. I'm going to share a video, and then what I will do is walk you through Tableau for Teaching and specifically what it is that we do as terms of technology and working with teaching. So I will share screen. I will make sure I share my audio as well.
If it doesn't work, you might have to talk over it.
No worries, no worries. Okay, let's give this a go. So first, can I get a thumbs up from Eric or someone I can see that you can see my screen? And now I'm going to
today is probably no way, right? There's no way that that was done in Tableau. Hello, everyone. I am Chantilly Jagannarth. I'm a two-time Tableau Zen Master and a Tableau Public Ambassador. About 10 years ago, I was a student at Howard University, and my professor asked us to make sense of some data, and I didn't know. So I just simply Googled what can analyze data, and I ran into Tableau, and I would say it was like love at first sight. The one word that I would use to describe the Tableau community is family. It just means the world to me, knowing that I have individuals that I can easily turn to, that I can easily just message, you know, some developers on or other Zen masters on, and they're always willing to help. My involvement with Tableau Public started about 5 years ago. This is when I was introduced to it by Josh Tapley. He was recruiting for a data visualization job on his team, and one of the requirements was that you had to have a Tableau Public page. Now, everything that I did up to that point was for a corporate setting, so I didn't have anything that I could upload to Tableau Public. So I started creating these visualizations and publishing them to Tableau Public, and I would say what really kept me coming back was the feedback and the interest that I got from the community. So it was really the community and critiquing my work and showing me better ways that I could create visualizations that kept me coming back. One thing that I recommend someone doing on the Tableau Public platform is scrolling through the viz of the day every single day. And that is what inspired me to take more of a design approach to my dashboards. Download some of your favorite vizzes and start to re-engineer them, and that's really what's going to set you on your path. Professionally, I would say the Tableau Public and just the community in general has enabled my growth career-wise. Tableau Public has impacted me personally because it was one of the driving factors as to why I created my own nonprofit organization called Millennials in Data. I saw that once I started publishing work onto Tableau Public, I had recruiters from some of the top companies within the world reaching out to me just because of this skill set that they saw that I had. And I decided that I wanted to give this same skill set to students who were in college who just have not heard of Tableau, who just haven't heard about data analytics in general. So personally, it's impacted me to have this mission, this personal mission to introduce data analytics and data literacy just to the younger generation. To not be afraid of the community. They're really there to help, right? So I see that a lot of individuals, when they first join the community, they're overwhelmed by the thousands and thousands of individuals that are there. So they probably sit more so in the background, but go ahead and offer some advice on a visualization. Go ahead and post a visualization and try to get some advice on it. Go ahead and join a community project and be involved and continue to grow your skill set.
Awesome. So thank you all for taking a look at it. And you might be thinking, we just did an analysis and we see that most people on the in this session are teachers. So why are we looking at this? I think the number one thing that we can all talk about is the fact that we're starting with our end product, our students in mind. So with that being said, I would love to talk about Tableau for Teaching and why are we on this mission? So with Tableau for Teaching, we really are on a mission in making a data literate world. I think we've all seen research that has said that, again, we have a surplus of data. However, how are we able to see, visualize, and understand that? As I stated before, being a professor, I think we can all say that, one, we want to prepare our students, and two, we want our research to be a value add. I don't know about you, but how many times have you paper or went into push a publication out, but who's actually reading it? I think the big piece is how do you grab. As you can tell, Chantilly was talking about those visualizations and how they're aesthetically pleasing. They're easy to manipulate. You don't have to worry about coding or anything like that. It's really looking at this platform and utilizing this resource and tool to kind of really divulge out. So with Tableau for Teaching, again, we do have one side. This is our mission side. We have instructor licenses. We have student bulk keys. What are student bulk keys? As a psychology teacher, if I'm teaching in the fall, what I can do is actually gain access for my entire course. So I can put all my students in this course and actually teach Tableau in addition to any of the other research and statistics, psychology curriculum that I am utilizing. We also have licenses. This is really huge, especially as well as having access in the community. So many universities will also have in their labs a resource that they can access Tableau for students. So students can come in, they can log in, and they can utilize the software. The huge asset, as we're talking about equity, even for me, that I've started really playing around with is Tableau Online. Why do I use that? It's because we talk about access. Many students may not have access to virtual tools. We learned this in the pandemic very quickly, that digital divide. So with that being said, they can now use a cloud-based workspace that's similar to the student bulk keys, but they can utilize this online site. It's a cloud-based, they can log into any computer, any laptop, any Chromebook. The other piece, that secret hidden gem, is our researcher license. I say that because I'm currently a PhD student and we are always doing research. Our eligibility requirements. So as you're going through this website, which I have already posted that link in the chat session, you can look at it and read the other requirements that are there. Now, I'm going to talk to you about the really stellar thing that I think separates us from many other tools or platforms. It would be a curriculum. So as we see, we had teachers who are in the room first. Okay, all teachers in here. We know that we don't always have is time, prep, and planning. Ready-made curricula that is available to you. And I'll click on the link just to quickly go through those. Data literacy 1 and 2, because we do believe data literacy is there for all. We also have data visualization, a 10-week curriculum. We have the introduction to data journalism with Tableau. We have media, and then there is a best kept secret in here in this August. What should be coming out is, 1, this curriculum will be able to be utilized in Canvas. So if you're utilizing Canvas, it will be there ready to go. So there's no more and upload, download, things like that. And then 2, we have a healthcare course that is coming. So I'm really excited about that too, because as we talk about data literacy, and data is for every discipline across all subject matters. So we do have our ready-made curriculum that is there as well. The other pieces that are there is, as you saw Chantilly talking about our community, we have a Tableau for Teaching user group that we ask questions, they answer back, they do their own thing. It's very vocal. They help each other out. About a month ago, I know that they even have where on their own, without Tableau's help, as a community, to get together to talk about their intro to data. And they talked about what curriculum, their syllabi, what they should be teaching. So it's a great way to network across the world to look at that. So with that being said, I'll stop there for a second to see if there's any questions. You can post those in the chat. And that's the Tableau for Teaching side. But I'm not done yet. Eric, please don't cut me off yet. So with that, as you're typing any questions about the Tableau for Teaching, because we have students in the room, we have Tableau for Students. Students, if you do anything else today, please, while you're a student and you get this access for free, complimentary, please take advantage of it. The reason for this is because if you do the Tableau for Students and request a license as a student, you get that e-learning that's right there. So if you're interested in data science, still want to dabble in it, or you're just interested in learning Tableau, you today to request that license and on those skills. And again, as Tilly said, it is huge opportunity. Over a little bit, I was sharing with someone the other day, for Tableau alone. So teachers, and when you're looking for a job and you're looking Tableau, the platform that we should be, as we already know, by the time a freshman comes in, by the time they're done, most of those skills have already kind of, all right, we're moving on to the next thing. But we're almost at we're a little over 97,000 jobs just in the US alone. The other, I'll show you, because we are global. This is the EMEA in the Europe area. We have 75,000 jobs with Tableau. And not Tableau the company, but as you can see, just jobs for people who are trained in Tableau. And then again, being global, we actually have APAC as well. 37,000 jobs. When I was doing the booth session, we had students in here. I was showing them that and they were like, I want to learn. I don't have a class, but I love to get started now and work on it. I even had a student yesterday said, not only do I want to learn, but I love to start a club and teach students community. And I just thought that that was absolutely amazing. So for all licenses, students and teachers, it is for 1 year, but it's renewable. So every year, long as you're a student, every year, long as you're teaching. And as I said, I've been teaching for 8 years, about 6 universities together. So I like to do the dance of the lemons to going from university to university. I can literally renew every year. So I will stop there with questions because I promise you I will go over time and I don't want to do that. But I'll stop here for any other questions. Anything you're excited about? I know this summer we will be having boot camp for students. So again, students who are in the room, if you're trying to ramp up those skills, they actually will have an interactive resume building. So they will teach you how to build your resume in Tableau, create visualizations. If you are trying to get certified as a student, you get a discount to get certified. And that's going on our website. They can see who's certified. Almost every other day, I get emails from people asking, hey, do you know someone who can teach a course or who's a consultant? So it is absolutely vital. And not only that, our biggest mission is just data literacy. Being able to take data and elevate that value add to the community, because that's what we're doing in academia. I think that's what we're trying to do, prepare for the workforce and trying to make an impact, our research be a value add. So with that being said, if there's any other questions, I am more than happy to answer. Lee, stop during my session talking about Microsoft. Give me a second. Just joking.
Okay, Jessica, thanks for your passion. I'm gonna move on to the next speaker if it's okay. It was Chris Policastro. Jessica, you could watch the chat if you get some questions in there. We can loop back to you later.
Well, thanks, Eric. I'll attempt to share my screen.
Looks good.
Okay, you can see my screen?
Yep.
Okay. I'm having some trouble enabling my webcam. However, I think we should be able to proceed with the presentation. So thanks, Eric, for the chance to share some information in the panel. I wanted to talk about automated grading as part of the broader discussion of educational technology. So like the presentation by Lee on Pyrobrite, I'll discuss automated grading, abbreviated auto grading, which has computers perform tasks typically handled by instructors. So here the computer processes assignments like a homework or projects. So I'll share some developments with collaborators at NYU on auto grading in the NB Grader library mentioned in the chat by Lee. The NB Grader library applies to the Python programming language. It's an auto grading tool that has some similarities and differences to other auto grading tools like AutoGrader mentioned by Christopher Piles the other day in the conference, in the session on Monday, June 14th. So like AutoGrader, NB Grader integrates with the Jupyter Hub platform, but unlike AutoGrader, NB Grader does not integrate with the Gradescope learning management system. So the focus for the presentation will be on connecting Jupyter Hub and Gradescope. I'll show you that the NB Grader library is not only a useful tool for grading, but an extensible tool for grading that you can modify for your needs as an instructor. Okay, so several presenters in the conference have shared information about Jupyter Notebooks with us. I'll just remind you that Jupyter Notebooks are development environments for the Python programming language, along with several other programming languages, including Julia and R, hence the funny spelling of the acronym Jupyter. So programmers in academia and industry have adopted Jupyter Notebooks for their combination of code, text, and charts in a web-based development environment. And I adopted Jupyter Notebooks for some of my classes on data science because they help to foster digital literacy among students with diverse backgrounds. So whether it's teaching in the humanities, sciences, or engineering, Jupyter Notebooks can be a helpful tool. for students, particularly when the Jupyter notebooks are provided through Jupyter Hub. So at NYU, technicians deploy Jupyter Hub for instructors and students. So I like to tell students that Jupyter Hub is like a cloud-based computer lab that provides computing resources and storage resources to students at scale. So students don't need to worry about the hassles of configuration. They have an accessible platform where they can work with Jupyter notebooks, and they don't need to worry about buying a device or installing applications on a device. So Jupyter Hub is a great way to kind of bridge the digital divide. We don't need to have disparities across a class because of lack of access to technology. So despite all the capabilities of Jupyter Hub, you should not think of Jupyter Hub as a learning management system. That's where Gradescope comes in. So Gradescope is a Berkeley-based company that provides a commercial product licensed for class management. And Gradescope integrates with other learning management systems like Sakai or Brightspace. And it has all sorts of useful features ranging from record keeping to regrade requests to similarity detection. And like we learned the other day from the presentation of Christopher Pyle on AutoGrader, Gradescope has growing support for Jupyter notebooks. So this prompted some developments around NYU to bridge the gap between Jupyter Hub and Gradescope. So before I show you a demonstration, I just wanted to outline a couple tasks that should be familiar to you in grading, particularly auto grading. So when it comes to auto grading, usually there are two versions of the assignment. There's an instructor version and a student version. And the instructor version contains questions, answers, public tests, and private tests. The students will just be able to see the questions and public tests. The idea is that the private tests are for assessment. And the assessment can be divided into two parts. Usually the code is assessed through auto grading, and the charts and text are assessed through manual grading. So I'll get back to that difference at the end of the presentation. But for the time being, I'll just point out that the next step in the process is to collect the student submission, perform the automated grading and manual grading, and then distribute the feedback along with scores to students on learning management systems like Gradescope. And from there, the students can check their scores or raise a regrade request. So like I mentioned, there are all sorts of software for auto grading and all sorts of extension of software for auto grading. We were just learning about Pyrobrite from Lee. AutoGrader and OKPy were both developed around Berkeley by Christopher Pyles and John De Niro, respectively. I want to focus on another approach, the NB Grader library, which was also developed at Berkeley by Jessica Hamrich. And it's been a useful tool over the years in my data science classes. So like some other systems, NB Grader is an open source software. So it's benefited from the contributions of a community of developers, including developers like myself at NYU. So what I'm going to describe are a couple of extensions to the NB Grader library that have allowed us to connect Jupyter Hub and Gradescope. So let me show you just a couple demos. Just to show you how we put those tasks I mentioned in the previous slides into practice, the instructor is going to generate the instructor version, which we see here. So as you can tell, it has questions, answers, public tests, and private tests. So the questions are going to have code and charts, being some combination of true, false, multiple choice questions, or numerical response. And generally, we manually grade the text. And we focus on the code for the auto grading. And what's nice about using NB Grader as opposed to other approaches like OKPy is we don't need to maintain separate configuration files. So all of the information is embedded in the instructor version, along with the student version that's generated from the instructor version. After we release the student version, students can fetch the assignment, modify the assignment, providing their answers to the questions. They can run the public tests. In particular, they can validate their assignment, so they can see how they're meeting the milestones set out in the assignment. And after they're ready to submit, they can provide us their submission on Jupyter Hub. So at this point, we collect the student's submission. After we back up the submission, we can calculate scores and provide comments. Again, we divide the grading into manual grading and auto grading. And lastly, we need to get the feedback, particularly the scores, to the students. So we need some way of getting the assignments from Jupyter Hub to Gradescope. So we worked with some of the developers at Gradescope to leverage their application programming interface. Actually, it's the same API that's behind other auto grading software like AutoGrader. So these developments were meant to contribute to the NBGrader package to show that it's not only a useful tool for auto grading, but an extensible tool. So you can find our work in a GitHub repository and a Docker registry. And I'll mention that even for NBGrader, there are other approaches. If you want to leverage Gradescope for your class without Jupyter Hub, I'll encourage you to check out some developments by Zach Ives at University of Pennsylvania. I think that his approach to working with NBGrader would be ideal for other classes where you don't have Jupyter Hub, but maybe another technology like Google Collaboratory. So just to conclude the presentation, I'll mention a couple of remarks. These are more general remarks that go beyond NBGrader to auto grading. I just thought I'd mention a couple of pros and cons of auto grading, especially in the era of COVID. So I want to point out that auto grading does have some cons. Auto graders can be hard to interpret, prone to errors, or inflexible. And this came up especially over the last year with COVID in some scandals, particularly the International Baccalaureate Program scandal. So I think what we're learning is that auto graders have their limitations, particularly when it comes to grading assignments with text. However, for assignments with code, I think auto graders can be pretty useful. So auto grading is traceable. You can provide reproducible assessment of an assignment. Auto grading is equitable, so you can accurately grade assignments in an impartial manner. And auto grading is efficient, so it allows you to have a faster turnaround on the feedback for assignments, and allows you to handle classes at scale. So this frees up time for the instructional staff, meaning the faculty and teaching assistant, to add value in other ways to the class. So just like asynchronous instruction, which is forced on us this past year with COVID, has components that teach themselves, automated grading has components that grade themselves. So this makes automated grading a helpful tool for remote learning. Okay, so I'll stop sharing my screen and I'll turn it back over to you, Eric. Thanks for your attention.
Thanks, Chris. That was really great. And thanks for giving shout outs to other people working in the field. I really like that.
Of course.
Naomi, you're next.
Thanks, Eric. Hello, everyone. Let me share my screen. Start the Hall of Infinite Mirrors. 1 second. There we go. Okay, so it's nice to meet all of you. I am here on behalf of the Cloudbank organization. And so before we get started, just a little bit about me. So my name's Naomi. I'm a tech educator with a deep background in computer science and electrical engineering, but I really just love sharing things with people, whether those are technical concepts or whether that's pedagogy and strategies for teaching and mentorship. Previously, I've taught data science and computer science courses at Mills College and the University of Illinois at Urbana-Champaign. But right now I am at the University of Washington's eScience Institute, which is their data science center on campus. I like to call myself their resident cloud computing Miss Frizzle. But really what I see my role there is to be a bridge between people who have curiosity about using technology for their own, purposes, for their own teaching and research purposes, and the technology itself, which may have been developed for other audiences and not have the most legible or usable documentation or examples out there. And to that end, I work very closely and put a lot of my time into the Cloudbank organization, which is an NSF-funded multi-university collaboration between UCSD, University of Washington, and Berkeley. And its broad mission is to be, to borrow an electrical engineering term, the impedance match between the commercial cloud and academic institutions. Or I suppose another way of putting this is being the philosophical interface between cloud vendors who are used to providing compute services for businesses and academic institutions who are used to doing research and running classes. And so as an organization, Cloudbank provides sources of funding for researchers and educators to use the cloud. And it also provides materials and advice to help people migrate their infrastructure to use cloud resources. I'm going to turn my laser pointer on because I love laser pointers. And I can't see the chat, so I'm going to periodically just, if you don't mind, switch tabs over and see how people are doing. Oh no, this impedance match is triggering PTSD from years in grad school. Yeah, it's just such a good analogy, I can't leave it behind. If people want to talk circuitry, more than happy to, but I suppose that was from a past life of mine. And so when I talk about cloud services, at least in the context of Cloudbank, and I think in the context of what a lot of us are looking at in this panel and at this conference, I'm not really talking about things like Google Drive or Dropbox, which we think of as being sort of cloud professional workspaces that provide a word processor and a spreadsheet program and a slide program. What I'd really like to do with my time on this panel is to give us sort of a moment to think about the general class of service that we are all thinking about using here. And that is to say, services that use computers that are provided by somebody else that we pay money for, be it on a traditional cloud vendor like Microsoft Azure or Amazon's Web Services or Google Cloud Platform, or an application-specific service like the ones provided by RStudio or Tableau. And in order to talk more deeply about this, I think that we have to first talk about what services these vendors are really providing. And I thought for a long time about this. How would you do a breakdown of like all the different Google apps, but for the cloud? Because it's such a broad field of things that you can do with it, and it can mean so many things. But I think that the unifying concept behind all of them is it's really stuff that you do with a server. That is stuff that you can do with a computer that's on all the time. So what a cloud resource is really doing is it's replacing the server that you would keep under your desk connected to the internet and plugged into a power supply that hopefully won't go out. Or maybe if you're at an institution that has the resources and the IT for such things, maybe instead of under your desk, these computers are in some data center on campus. But what we see the cloud really doing now is sort of democratizing access to the ability to leave a computer on all the time. And that lets you do all sorts of cool things that we've been seeing throughout this summit, like, provide instant coding environments with Jupyter and Jupyter Hub. I find just as an educator, one of the coolest things about providing an instant coding environment, whether it's through Jupyter or it's through RStudio Cloud, is that students can just immediately get started. At least I know when I'm like teaching a class, I am super worried about people rage quitting their class and dropping it before the drop deadline, when really the problem was just that they were stuck on the hardest part of all of this stuff, which is just getting the environment set up. And being able to point them to URL and say in the middle of the first lesson, hey, why don't y'all just like open this web page and try some code out? I found has been a really powerful pedagogical technique. And so I think that the cloud and learning how to use the cloud effectively is a really great way to bring interactivity and bring accessibility to your technical classes. I also think that the cloud can provide sort of offline learning materials in a really effective way as well. We've seen an increasing trend with programming textbooks like the one that Data 8 uses, computational and inferential thinking, that when you open these things in your browser, you can run the blocks of code live on the page, or pretty easily move the code to an online coding environment that lets you do so. And as cloud tools get more accessible and more usable, it's easier and easier to write your own sort of textbooks yourself with technologies like Jupyter Book, or technologies like in the R side of the world I think it's called Bookdown. There are a lot of options here, and they all boil down to being a conversant enough practitioner of using servers, whether those servers are ones that you used to keep under your desk, or whether they are ones that you are paying Google, Microsoft, or Amazon to run for you. But of course, doing all of this takes skills, and as teachers, I'm sure we all feel crunched for time. And I think that, at least for me, when I'm starting to spin a class up, these are the real stumbling blocks. These are what stop me from trying to use an autograder or trying to set up a Jupyter Hub. These are skills of infrastructure management. Rather than just thinking about the syllabus, now I have to identify and use what cloud resources are the right things for the right tools for the right job. Ideally, once we get past a beginner level of using cloud resources, we go to intermediate concerns like staying platform agnostic. So if things don't work out on one cloud platform, you'll be able to move to another without losing all of your work. And of course, this is something that I am constantly worried about when I don't have departmental backing with a budget that I can draw on, is monitoring ongoing cost, because running servers costs money. And it's a really scary thought that your compute resources might run out in the middle of a really big assignment towards the end of the semester. And so this is really what Cloudbank was founded to help with. Most of our focus has been on researchers, but the truth is, when you're running a class, these things come up as well. And we're happy to engage with the educational community to work on their skills for these things. I'm gonna break to look at the chat for a second. Yeah, there's a lot of changes have been happening in the landscape over the past decades. So to just touch on these things for a moment, I was thinking we could talk a little bit about designing cloud resources to be platform agnostic, and maybe a few other topics like cost estimation. But when we're talking about all of this software that you can use to run your class infrastructure, I think that there tends to be a trade-off that we have to make between flexibility and simplicity. So just to use a Jupyter notebook as an example, or writing Python code to do data science as an example, the most flexible way to let a student run Python code in Jupyter is to start a virtual machine that is a virtual server running in the cloud that is running Jupyter. And this is an incredibly portable approach, because what you're effectively asking Google or Microsoft or Amazon to give you is just a computer that you can log into remotely, install software on, and run open source server software on. And moving down the stack, I suppose this isn't quite as simple as running a server with Jupyter, but if you want a bunch of students to be able to access Jupyter at the same time, then you'll probably want to run something called Jupyter Hub, and we've seen a lot about what that is. But then there's this notion of what servers are backing the computation on Jupyter Hub. And this is where different cloud platforms have different ways of running little clusters of servers that might be more cost-effective and useful for you. And then moving on from that, a lot of these cloud platforms offer ways to just upload a Python Jupyter notebook to the cloud and interact with it directly without having to set up any server software or any computational clustering. And these can be very effective and very useful ways of getting work into the cloud fast. But you're trading off for all of that management, a lot of flexibility in how things are configured. And of course, you're now using vendor-specific tools that will change from one platform to another. And so once you're, I think this slide is for people who are really beginning to think about their course infrastructure as something they own rather than something that they are trying out for the first time. But once you're happy with how your class works using cloud resources, these are the kind of questions that you can ask yourself. How much flexibility am I necessitating versus how much simplicity and managed service am I trading off for that? How much money am I saving by running a managed service versus platform portability by doing everything myself? And of course, this all sort of comes down to cost, which can be rather hard to estimate when you're talking about running your own cloud services. We find that when we're talking about courses that use notebooks, the real questions to ask yourself when you're costing something out before the semester starts are how many students are going to be enrolled in the course? Will those students need persistent storage in the cloud? That is, are they going to have like a network drive that they're keeping their work on? Or are they just going to log on, do an assignment, submit it, and log out, and they don't need to access it again? How many students will be using the environment at one time? That is, are you going to have one lecture session of 100 students that all are going to log on to the same lab webpage when you tell them to? Or is that lecture session going to be split into multiple sections of 20 students? Or is all of this stuff going to be recorded and they'll be watching it on their own time, at which case they're all probably going to be logging onto this website at different times, and so the load will be more balanced. We really find ourselves beginning to have to act like web operations people managing popular websites when we're considering, how many people are going to be trying to do their homework at once. Not that this is a new situation to cloud learning. I have very strong memories of taking classes that required HPC simulators back when I was in grad school, and everyone trying to do their assignment at the last moment and bringing the server down. So you needed to make sure that you got things working ahead of time. But these are the same sort of questions that you ask when you're provisioning your own Jupyter hub. Is there a lab session? Is the whole class running at once, or is it split into smaller sections? And so in practice, what we've found is that a rough ballpark number, and we're still really working on getting a good estimate here, but a rough ballpark in 2017 was that running a Jupyter hub for an intro to data science course or an intro statistics course ended up costing about $4 per student per month. Which isn't a huge number, but it's not nothing. What we found, though, is that this number has actually been going down as course management software for the cloud gets better and as cloud services get more and more commoditized and easily accessible. So we found more recently that it was costing us about $1 a month to give students access to this live coding environment throughout the semester, including persistent storage. That is giving them a little network drive space in the cloud to do their work. And we can only assume that in the future, this number is going to keep going down as well. Though there are a lot of folks at Berkeley who are doing a lot of work to both make this figure go down and also make it more accurate so we can more clearly estimate how much things are going to cost. But the heart of all of this is, I think, that having course infrastructure beyond static learning materials is really worth it. It really provides a rich environment that a lot of students can get a lot of value out of. But we're having to build some extra skills in order to do it well and in order to do it cost effectively. And that's really what Cloudbank and the other organizations present at this conference are all here to help you do. So as far as getting money to run things in the cloud for your class, there are a few sources. We have Chris from 2I2C, I'm sure, is going to talk a lot about how you can get a Jupyter Hub spun up for your class through that organization. In which case you don't have to think about most of the things I just told you about. I think this project is currently prioritizing community colleges and HBCUs, though, of course, the hope is to, over time, have this become a more well-established program that serves lots and lots of different types of organizations. Cloudbank itself also offers community grants. These are grants that are, rather than running a Jupyter Hub for your class, is if you have any other ideas for course infrastructure that could benefit from leaving a server on 24/7 so a student or a TA can do something at 3 a.m. on a Saturday. We provide semester-long grants of cloud credits that you can use to run course infrastructure. And those grants are typically in the $500 to $1,000 range, which, especially for non-student facing things, tends to be, we think, more than enough. But of course, this number is flexible. And you can always submit a proposal. And I'll drop this link in the chat as soon as I'm done with this presentation. But this link goes to our website where you can get some guidance on submitting a proposal. We check those proposals on a rolling basis. It's not based on any semester calendar. And see if we can get you some funds to do some cool things. Because really, when it comes to, cloud-based course infrastructure, the sky's the limit. There are so many cool ways to use remote computing that I've seen beyond even what I talked about in this presentation. I've seen CS security classes use the cloud to provide virtual machines for students to hack into. I've seen people run live wikis on cloud resources for students to sort of modify and build a corpus of knowledge as things go forward. There's just a lot of power here that I think is really cool to tap if you have the spoons for it, if you've got the resources. And with that, I'll turn the mic back over to
Thanks, Naomi.
Eric.
I'd like to bring Chris Holdgraf up, but Naomi, I think there's a couple questions and comments in the chat that you could respond to while Chris goes. If you go down the bottom, there's a picture of a television next to a gear. Yep.
Yeah, I was doing so well, and then I got confused and lost all the buttons. All right. How much persistent storage per student? That's a really good question. It depends on how things are accessed. I believe that we generally see that the cost of storage in the cloud tends to be, I'm such a bad numbers person, but I want to say, man, I had a slide with this number on it, and I think
it's a really hard question to answer live.
It's a hard question to answer live. The answer is either 2 cents per gigabyte or 20 cents. It's not 20 cents per gigabyte. I want to say 2 cents per gigabyte, but again, it really depends on how the student is using that data. Who would be the go-to person if I have questions about Cloudbank? That is an excellent question. I would be great. My colleague, Rob Fotland, is also a great person to talk to, but really just
here
email.
in the room.
Yeah, Rob is here. If you email help@cloudbank.org, that goes to our help desk, which ends up getting seen by everybody in the organization. So that's probably the best way to submit questions.
Okay, I want Holdgraf to get a chance to start.
Yeah. Okay. I'll answer the rest of the questions in the chat. Thank you, everyone.
Okay, can I get on?
Yep, go for it.
Okay, cool. Let me see if I can get screen sharing to work. This works like 1 out of every 5 times that I try in life. Okay. Window. Okay. I assume folks can see my screen.
That's great. Yep, you're great.
Okay, cool. So thanks, Naomi, for that awesome talk. I feel like I could basically just not give a presentation because I basically agree with everything that Naomi just said. But maybe I'll cover some of the similar topics and have a more specific focus on a project that we've been working on lately called the International Interactive Computing Collaboration, or 2I2C for short. So first, maybe a bit about myself. So my name is Chris Holgraf. I'm the director of 2I2C. I actually had a background in a more traditional academic path. I was a neuroscientist at Berkeley for many years. And while I was doing that work, I got more and more involved with the infrastructure team at UC Berkeley. So the team of people building tools in the Jupyter ecosystem and building infrastructure for Data 8 and many other use cases around research and education at the university. A lot of the tools within the Jupyter world that I work on are Jupyter Hub, the Binder project, and Jupyter Book, many of which you may have heard of in some of these sessions here. And so what I want to talk about today is sort of how all of these pieces interrelate to one another and how they relate to teaching and education and what 2I2C is trying to do to address some of these challenges. So people often ask me what Jupyter is. Like, is it a product? Is it a technical platform? Is it an ecosystem of tools? And I just like to quickly give my definition, which is that I think of Jupyter primarily as an open community of people. And this community of people are joined together by an interest in creating modular platform agnostic tools for interactive computing. And those tools span many different pieces of the stack, as you've probably picked up from hearing about all the different kinds of pieces that people have used for teaching and education. But I think it's important to emphasize that one, that community is open. Anybody is welcome to join. Anyone is welcome to be a part of Jupyter. And two, the tools that we build are meant to be like modular and compartmentalized and interoperable with one another. So you don't have to use everything. You can use different pieces and sort of take them with you wherever your workflows are. So what do I mean when I say interactive computing? And what I like to do for this question is cover a couple of use cases, one of which will be very familiar to you. So in my mind, interactive computing broadly covers really any situation where there's a human that is like directly synchronously interacting with a machine. So maybe that's sitting doing some data exploration, maybe that's sitting next to somebody else and showing them a question or an idea that you've been working on. And the Jupyter project builds tools that facilitate these kinds of high bandwidth, human in the loop kinds of interactions. And probably the most well-known components around this are user interfaces. So the Jupyter Notebook interface or the Jupyter Lab interface, which both facilitate, they're an interface that facilitates your interaction with the computer and getting that rapid feedback. And there have been a couple of really interesting examples over the years that we've been working on pretty heavily that feed into this question. So one of them is using the stack to facilitate large-scale data analytics research or to provide people access to resources they otherwise wouldn't be able to have access to. And to highlight this example, I want to talk about a project called Pangeo. So Pangeo is a community platform and a community of people that are dedicated to large-scale geospatial analytics in the cloud. And really one of the main challenges that Pangeo tries to tackle is that increasingly in the geospatial world, they have really large data sets that are being generated from satellites. Those data sets are hosted on cloud infrastructure, but they don't have a choice over which cloud provider that infrastructure or that data lives on. And so they need to have a technical stack that both facilitates access to that infrastructure, but that also can be deployable across any of the different cloud vendors that are out there. And they've done a ton of work contributing back into the Jupyter ecosystem towards this use case. So as one example, this is just a little widget that the Pangeo community has built. And I just want to tell you really quickly what's going to happen. So we're seeing an image of a satellite. And what someone's going to do is they're going to create a little square. It's going to zoom in on that image. And then we're going to see the resolution update itself. So we zoomed in. It's a little bit blurry. All these bars on the bottom are doing stuff. And after a couple of seconds, the image just updates itself to a new resolution. Now, that seemed kind of trivial, but under the hood, what was happening is that when a person zoomed in on that little window, it was triggering a bunch of what are called Dask workers to churn through like 10 terabytes of data that live in the cloud, recompute the new magnification level, and then update the zoom on the fly in order to allow you to look at whatever you're trying to look at. And that, I think, is a really great example of interactive computing in action. You're doing this really complicated computation, but you're facilitating the access to it with something as simple as like a click and drag zoom. All of the tech stack in the Pangeo ecosystem is made up of these modular open source components that I described before. So I'm not going to go into a ton of detail on this slide. Really, the point is to just say that sort of each tool has its own part in this ecosystem, and it all works in an ensemble together. And moreover, everything in Pangeo is deployable across any of the different cloud providers that you might need to have access to, because it's built entirely with community-driven, open source, vendor agnostic components. So another really great example of this that you're all probably very familiar with is teaching data science. And I think that the best example of this that I know of is the Data 8 class at UC Berkeley. I'm not going to go into a ton of detail on this because I'm pretty sure that everybody here already knows what I'm talking about. But suffice it to say that if this is the room of people that you're trying to teach data analytics to, then if you needed all of them to install their own environment on their laptops, you would probably waste about 2 to 3 months worth of class time just getting everybody up and running. And so Data 8 uses a Jupyter Hub to provide remote access to all of their infrastructure. But what I think is interesting is the connections that exist between the different tools that Data 8 uses and the shared infrastructure that they run in the cloud. So as an example here, you've seen it a couple of times. This is the textbook that Data 8 uses, and it's built with a tool called Jupyter Book. So you have, the content across your different pages. This is built with Jupyter Notebooks under the hood. But this little launch button up here allows you to connect a Jupyter Book with a Jupyter Hub or a Binder Hub that's running in the cloud. And what this means is that students can really quickly jump from this static, much more accessible version of the content into a much more rich, interactive version of the content running on shared infrastructure that's managed by, a course administrator or a course university. And so there they can really get their hands dirty and dig into the computational content a lot more. And again, the diagram of components that make up the Jupyter Hub for Data 8 is very similar to what we looked at for Pangeo. They actually reuse maybe like 70, 80% of the same components. And I think that's really cool that you can basically use 80% of the same infrastructure for a large scale geospatial analytics platform, as well as for this very different use case in large scalable data science education. So I think that all of these examples have been extremely good success stories in what I call a model of production that follows curation, customization, and then contribution. So they choose from open source modular components that they need for their problem. They customize those components and make them ready for their particular use case. And then when they need improvements, they make those improvements by contributing back to open source communities rather than developing tools that only are controlled by them as an organization. This has a bunch of different benefits. You get to have full control over the infrastructure. Your tooling is completely vendor agnostic. You can run it on any different cloud provider. You're making improvements to tools that everybody else uses as well. And because this open source stack has become a kind of standard across both the academic and the research community, people are using tools that they're going to take with them wherever they go. So whether they go into grad school or whether they go and get jobs in the tech industry, or whether they go and get jobs in a non-technical industry, but where they might do data analysis, you can make a pretty safe bet that Jupyter infrastructure and these open source components are going to be useful and present for them. So the challenge, though, is that these tools, these success stories have been really hard to replicate. And I think that's for a couple of different reasons. For one, it turns out that DevOps is hard, as Naomi mentioned in the previous talk. Over the years, we've run, as a part of the Jupyter project, a bunch of different courses, and we've created material, we've created documentation, we've run boot camps and workshops around managing your own Jupyter Hub infrastructure. But at the end of the day, what we've learned is that for a lot of organizations, it's still just a bridge too far. Managing your own, littlest Jupyter Hub on a single VM or managing a scalable Kubernetes cluster is really, it requires a skill set that's outside the norm of most people who are in universities, and particularly for people who are in smaller, community colleges and things like that. And so deploying this infrastructure, managing it on their own, was kind of a non-starter for a lot of groups that we would work with. What that led us to think is that we need to have more vendors that are sort of in between this spectrum of, on the one hand, you have like full-blown software as a service. You're just paying for access to a platform, but it's kind of a black box. Maybe it relies on proprietary services and APIs. On the other side of the spectrum, you have like a full-blown DIY consultancy where you need your own full-time cloud engineer. We thought that there was a need for services that existed in between these two sides of the spectrum. The other challenge that we've run into continually over the years is that sustaining open source communities is really hard. This is just one example of the impact that the Jupyter ecosystem has had. And this is a project that a guy named Peter Parente runs that just estimates the number of Jupyter notebooks that are on GitHub. And if you look at this, we're nearing more than 1 million notebooks. And all of those notebooks are by people who are using Jupyter, and it's rising kind of exponentially, which is really exciting. But it's also a little bit terrifying because I can guarantee you that the amount of resources available to the Jupyter project has not scaled even close to this rate. It's arguably even gone down a little bit since Jupyter was first founded. And as you get more and more users, you also have a lot more needs. What was originally just a single notebook repository in the Jupyter ecosystem is now a collection of literally dozens of repositories, each of which have hundreds of users, each of which have hundreds of issues. And so there's a really significant amount of work that needs to be done to sustain this ecosystem and to give back. So this also led us to think that we need to have more services that are basically committed to doing their work by contributing back into the open source ecosystem of tools that they're leveraging inside of their services and their products and things like that. So could you imagine a service that would basically take use cases in research and education, serve those use cases, generate resources from that, commit those resources to improving open source tools that then benefit the broader community itself, and you create this kind of virtuous cycle here. So this is what led to us creating a new nonprofit organization earlier this year called the International Interactive Computing Collaboration, or 2I2C. So 2I2C is a nonprofit initiative. It was launched in partnership with the International Computer Science Institute called ICSI. And the goal of 2I2C is to be a service provider that specializes in interactive computing infrastructure in the Jupyter ecosystem and in the sort of surrounding ecosystems therein. It wants to be a collaborator with an explicit focus on the research and education community, as well as a core contributor and a leader in the open source communities that underlie all of this infrastructure. It was founded by a bunch of project leaders, both within the Data 8 educational environment at Berkeley, with the Pangeo project that I mentioned before, and with a few other interesting experiments in interactive computing at scale, such as the Syzygy project in Canada. So it's people that have got a lot of experience in meeting these needs and also who have a lot of experience in the open source community. And the primary thing that 2I2C is going to try to work on is what we call Jupyter Hub distributions as a service. And this is effectively a way of creating a customized, curated combination of open source packages and modular tools built around a Jupyter Hub as the central focal point of providing access to those tools and the environment and the data that you want to provide access to. But where everything is entirely transparent, it's built entirely with open source components, and it's done so in partnership with open source communities so that you know that the work that's being done to create these distributions is also benefiting the open source community and the broader community as well. So we're starting with several use cases focused around one, scalable research, like what I described before, two, collaborative education, like what we've experienced with Data 8. And we're also exploring a few other use cases that we want to tailor some of these hubs for. Probably most interesting to me, at least, is in reproducible publishing pipelines, but we're still working towards prototypes of those. And importantly, I think that one of the guiding principles of everything that 2I2C does is following what we like to call the customer's right to replicate your infrastructure. And without going into too much detail, I think that the important part here is that the right to replicate your infrastructure is something that we should all enjoy, particularly in the research and the educational community, the communities that are dedicated to public goods and to public communities everywhere. And the right to replicate gives you the right to replicate that infrastructure in its entirety, wherever you want to, either with or without 2I2C, or really with or without any vendor, because we think that we need more vendors like this out there in the ecosystem. So what I just described right now is like a pretty high level sort of aspirational picture of what 2I2C wants to do. Right now, what we're doing is building pilot infrastructure to try and map on Jupyter distributions to these different use cases. So we're partnering with Cloudbank and with UC Berkeley around providing educational Jupyter hubs for Data 8 and for the, the community colleges and HBCU communities. We're partnering with the Pangeo project to see if we can provide that scalable research environment for other communities outside of the geospatial world. So like the neuroscience community or other sub-communities within oceanography or satellite imagery, that kind of thing. So if you're interested in learning a little bit more about these services, if you're interested in maybe working with us on a pilot hub, then please don't hesitate to reach out. We're still playing around with and experimenting a lot of different models around sustainability and what kinds of services we should offer. And really what we want to do is design 2I2C to be the most useful kind of organization that is nonprofit and mission driven and values aligned with research and education that can solve some of the problems that we've been talking around here, around how it's difficult to run your own cloud infrastructure, but you still want to use these vendor agnostic, open source, community driven tools. So that's it from me, a little bit about 2I2C and some of our background. Here are a couple of links in case you'd like to follow up and learn a little bit more. And I'm happy to chat either here or offline if anyone has more questions. So thanks very much.
Chris Holdgraf. Good stuff. Some good discussion going on in the chat. Not sure where to take it next. We have about 10 minutes. I don't know if any of the panelists want to reply to anything verbally. Yeah, I would just say to the last comment about are there Jupyter notebooks, if you go back to my talks on Monday and Tuesday, we try to share, we have giant libraries of Jupyter notebooks for teaching. So that's part of the magic of it all, right? Is that it's a reproducible document, and it's easy to take other people's curricular materials and change them up. And, people have been talking about this for a couple of days where like they took the data 8, they changed out the Berkeley example for a different example. So yeah, lots of examples there. What do Berkeley students do when they graduate and they don't have like this beautiful Jupyter Hub? Well, that's a great question.
I mean, what I've found from my own data science courses is that students really benefit from having these platforms initially when they're learning a tool, and that gives them enough motivation to install it locally on their own computer. Like the real value that this brings is orchestrating these large platforms full of people all in one cohort at the same time. But you can always bring these tools locally. Like unlike something like, I don't know, a really high performance, like super mega parallel genomics crunching platform that you can use the cloud for, like most of this stuff is stuff that you could run on a 2012 MacBook,
Yeah, I work with the honor students in data science. They all are pretty optimized out on what their local install is. And then, for their honors thesis, they're getting some, credits on Azure or, wherever they can get their credits to run their machine learning crunching on the cloud to do the application. So people definitely have like a pathway to owning it for sure as they leave. But it's a great question.
The other thing I think worth noting there is that we, when we teach courses, either at Berkeley, but I think in general, it's really important that this technology doesn't allow, it shouldn't serve as a replacement for teaching students how to work on their own. I think that it's really important to teach students a stack that doesn't make them dependent on any particular service. It's why I like Jupyter, because it's a completely modular and sort of vendor agnostic tool chain. But I think that from the perspective of Jupyter Hub, what it allows you to do is basically choose as an instructor when you want to cover that topic of like working on your own laptop and managing your own environments and things like that. It's a super important topic to cover. It just means that you don't have to do that as like a precursor on day 0 class, because that's usually going to frustrate a lot of students. It's a tough topic to begin with. And so having this managed infrastructure, other than just providing access to cloud infrastructure that literally would otherwise be inaccessible, right? Like these, petabytes of data and stuff. It just allows you to kind of have more control over how the experience of working as an individual fits in with your curriculum in a data science course.
That is such a great way of putting it, Chris. And like, I think to that point, like in the past, when I've had data science classes, I've used cloud resources for the first 1 or 2 assignments so that students aren't rushing to get things working in a way that tends to not be equitable and leave people behind who don't have those tech administration skills that others are used to. And then by week like 3 or 4, everyone's had time to install their own things and we don't need to use the cloud anymore. It's really nice to have that flexibility in your own lesson planning.
I was just going to say exactly the same, Naomi. So I think the key thing is really around storage, and lots of people have asked the question in the chat, is you have to build an infrastructure that allows students to use their own equipment, use GitHub, take that content with them wherever they go so they can take that content once they leave. So I would say storage strategies is the most important. Again, creating isolated storage away from the compute. So, if your Jupyter Hub environments go down, students can still go to those notebooks and consume them in your alternative way.
Yeah, Tyler brings up a really good question, I think, which is, isn't there a lot of necessity in teaching the desktop versions of these tools? Like in the context of R, we have R Markdown. That's a really good point. I think that there's always this balance of trying to teach the tool, which is going to become obsolete or different within a few years, but still very immediately useful, and trying to teach principles that they can use for any of these tools. But yeah, I don't know. It's hard to balance.
I work with students that build curriculum while they're at Berkeley, and I also think about them. They have a portfolio by the time they graduate. I tell the students, green dots on GitHub. If you're going for a certain sector of jobs, that's what the person interviewing you is going to look up. And being able to have a commit history of creating things over a couple of years. That's going to take you right from being an academic into the work world as well.
Yeah, and I think, again, having students build those repositories and portfolios is really key for employability. It's about how do they demonstrate the skills and experiences they've learned. What's their portfolio piece? How, did they do R? Did they do Python? Did they go on to doing deep learning, machine learning? They have to demonstrate it.
Can I just really quickly answer a question that somebody asked about Colab versus Jupyter Notebooks?
Yes.
So just to really quickly highlight that question, because it kind of gets to what we were talking about before around modularity and composability. So somebody was asking about the difference between the Google Collaboratory and the Jupyter Notebook interface. And I think that there are a lot of different differences between them. Probably the major one is that Collaboratory is just a Google product, whereas the Jupyter Notebook is created by the Jupyter community. So that's this kind of broad multi-stakeholder community. But I think that another important piece of it is that the Collaboratory only works within the Google service that you might use. And so if you don't want to use that interface, then you can't use that service. I think that the point of Jupyter's kind of modular composable approach is precisely that we want you to be able to use the exact same interface, regardless of whether you're working on your laptop or on your mobile phone or in some hosted cloud resource from a cloud provider or in some hosted cloud resource that you run yourself, like a Jupyter Hub. I think that the point is that all of these different use cases shouldn't require you to map onto different interfaces and different workflows. We want it to be the same workflow for all of it. But the only way to make that possible is by building tools that are use case and vendor agnostic. And so that's kind of the approach that Jupyter takes.
Yeah, I didn't even know a while ago that Jupyter could actually support RStudio for web. Someone was showing me that you can go from a Jupyter Hub file manager straight to a self-hosted RStudio cloud instance, and I was just like, oh, where was this when I was teaching data science 101? But I was surprised to see that Jupyter is yeah, you don't need to use the Jupyter Notebook interface. You can use another one.
It's really interesting as well is just the kernel support. So there's things now like .NET Interactive, which is C# in Jupyter. So, you can teach C# through a Jupyter experience. So it's going from data science into general programming now.
Yeah.
It's pretty swanky.
And the notebook itself, I would argue, is a great example of the value of building on top of standards and trying to define sort of like multidisciplinary, multi-stakeholder standards. Because, I mean, I would argue, in fact, that if Jupyter just ceased to exist right now and stopped all development, the biggest impact that it will have had is just the existence of the IPyNB file format. The fact that there is one format that we can all agree is like, this is a Jupyter notebook. And basically any notebook-based interface will know how to read that in because it's just become so ubiquitous and so common. Whether it's open source interfaces or proprietary interfaces or whatever. And it's really hard to get everybody to just adopt the same thing. And so I think that there's an incredible amount of value in doing that, and particularly because that thing is something that is driven by like an open participatory process to decide how that standard evolves, which I think is pretty cool.
We have a question about our Shiny apps. I don't know, Chris, do you know more about that?
Where are you at? In the chat.
So
Yeah.
Jana,
Yes. So we're working on that Shiny answer actually right now. So we're converting, like the Stat 20, like the intro stat class, and the new instructor wants to do a bunch of Shiny, but 700 people teaching at scale. It's going to overload, other Shiny. So we're thinking of using the Jupyter-based approach where everyone's getting their own, it's already set up so that every student can provision their own at any given time. So we are going to be piloting running Shiny in at scale for an intro stats class.
so Chris, you just picked up on a really good thing there, is that the virtual desktop from a Jupyter Hub. So I know that one of the things that Berkeley do is you have Visual Studio Code Jupyter Hubs. So a student can go into the Jupyter Hub environment, but then launch code in Jupyter Hub, which is like really cool as well.
Yeah.
Yeah, I mean, in my experience, usually when you have teams, you'll have different team members that are more comfortable with certain tools over other, or that like want certain tools that are geared towards particular parts of the workflow. So like for me, with the hubs that I've worked with, we use, like, I personally prefer to use VS Code when I'm developing, and I prefer to use Jupyter Lab when I'm doing data analysis and more like exploratory work. And so I think it's super useful to be able to just jump back and forth between those interfaces within the same kind of cloud environment, so that you don't have as much like friction in moving from one to the other.
All right, we should wrap up. I don't know if Jessica or Chris, you want to come back and just say bye, but thanks everybody for a stimulating panel. Thank you, Jessica. I think you got a lot of interest in the chat earlier on, and I think you got some context there.
Absolutely.
And, great. And thanks, Chris, for your Chris Policastro, for your contributions as a teacher and showing us that like the teachers can be contributors to the projects as well.
Oh, of course. Thanks for the opportunity.
I put everyone's slide decks up on the data.berkeley.edu site. I think they're rich, and go in there. I think for the Tableau, it's definitely like go to the Tableau site. A lot of what Jessica was showing is really easy to find on the Tableau site. I have started following Jessica on, maybe it's LinkedIn, but I keep seeing cool examples and cool other people making curriculum. So there's good examples out there of Tableau applications with compelling curriculum. So thanks everyone, and you can come by and meet a bunch of these folks in the vendor booths if you would like to later as well. So please check out the expos, and we will have another round of lightning talks in half an hour.
Thanks everybody.
Thank you.